All right, today in Algebra 2, we're going to look at section 3.2, the first day of it, adding, subtracting, and multiplying polynomials. Our essential question, how do you add, subtract, and multiply polynomials? So after today, we should be able to add, subtract, and multiply polynomials. Okay, so we're going to start out adding and subtracting polynomials. Okay, these are nice and easy. You simply combine like terms. Recall that in order for terms to be like terms, the variables and their exponents must be identical. You will always write your answers in standard form. The degree of a multivariable polynomial is the greatest sum of powers in any term. All right, so we're going to add or subtract. So 6x cubed plus 4x plus x squared minus 7 plus 2x cubed minus 8x squared plus 3. So I combine like terms. So x cubes with other x cubes. So this with this. Okay, x squareds and x squareds. X's, that's the only x I have, constants and constants. So 6x cubed plus 2x cubed gives me 8x cubed. And I'm going to do my squareds next. I have x squared plus negative 8x squared gives me minus 7x squared. Then my x's, all I have is a 4x, so plus 4x. And then my constants, negative 7 plus 3 gives me negative 4. There's my answer, standard form. Number 2, 3x squared y squared plus 2xy squared plus 6x squared minus 2x squared y squared plus 3xy squared minus 2x squared. X squared y squareds go together, xy squareds go together, and x squareds go together. But here I just have to remember it's subtraction, so I need to distribute the negative to everything. So 3x squared y squared minus 2x squared y squared leaves me with a 1x squared y squared, or x squared y squared. 2xy squared minus 3xy squared. So 2 minus 3 is negative 1, so minus xy squared. 6x squared minus a negative 2x squared, so that turns to 6 plus 2, turns to plus 8x squared in standard form. All right, number 3, 2a squared b squared plus 3ab squared minus 5a squared b, all of that minus 3a squared b squared minus 9a squared b plus 7ab squared. Again, a squared b squareds go together. A b squareds go together, and a squareds b go together. All right, so 2a squared b squared minus 3a squared b squared. 2 minus 3 is negative 1a squared b squared. So now I want to go with my next a squared and b's. Right? So negative 5a squared b minus negative 9a squared b. So that turns to negative 5 plus 9 turns to plus 4 a squared b. So now all of my a squareds have been taken care of. Now I will go to the b squareds. So ab squared, I have a 3 minus 7. So 3 minus 7 minus 4ab squared. Number 4, 4a to the 4th minus 6a cubed minus 3a squared plus a plus 1, all of that, add with it 5a cubed plus 7a squared plus 2a minus 2. So I start with my a to the 4th. It's the only one I have, but it's the highest exponent, so it stays out here, 4a to the 4th. That's the very first term. My a cubes are going to go together. Negative 6a cubed plus 5a cubed gives me minus a cubed. Next are my a squareds. Negative 3a squared plus 7a squared gets me plus 4a squared. And then my a's. A plus 2a gets me plus 3a. And finally my constants. 1 plus negative 2 gets me minus 1. Next, we're going to look at multiplying polynomials. To multiply polynomials, we use the distributive property. Then we combine like terms. Okay? So number 1, 2m plus 5 times 3m squared minus 4m plus 2. So distribute. I distribute the 2m with all three terms over here. So 2m times 3m squared gets me 6m. Remember, I add my exponents, so 1 plus 2, 3. 2m times negative 4m gives me negative 8m squared. 2m times 2 plus 4m. Now I take the 5 and I distribute it to all three terms over here. So 5 times 3m squared gets me plus 15m squared. 5 times negative 4m minus 20m. And 5 times 2 plus 10. So I've distributed. Now I combine like terms. So 6m cubed, that's the only m cubed I have. Combine my m squareds, so negative 8m squared and 15m squared gets me positive 7m squared. Now my m's, 4m minus 20m gets me minus 16m, and then my constants plus 10, making sure that I am in standard form. Number 2, 6n squared minus 7 times n squared plus n plus 3. So again, distribute 6n squared with all three terms over there. So I get 6n to the 4th. 6n squared times n gets me plus 6n cubed plus 18n squared. Now I distribute my negative 7. So I get minus 7n squared minus 7n minus 21. Combine like terms and put in standard form. So 6n to the 4th stays out front. Plus 6n cubed. 18n squared minus 7n squared becomes plus 11n squared minus 7n minus 21. Nothing to combine there. All right, let's go to the back. Here I am multiplying, I have 3 of them to multiply together. Mn plus 1, Mn minus 2, Mn plus 4. Okay? So take 2 of them and multiply together or distribute. Okay? And then we'll worry about the last one. So basically FOIL method here because they're both binomials. So Mn times Mn. Okay, so this is, I'll just write out what I'm doing. Mn plus 1 times Mn minus 2. This is what I'm doing first. So Mn times Mn, that's m squared times n squared. Mn times negative 2, so minus 2Mn. I distribute the 1, so plus Mn minus 2. I'm going to go ahead and combine like terms there. So I get m squared n squared. Negative 2mn plus mn gives me minus mn minus 2. So that's what I get when I multiply the first two together. So now I want to take that, multiply by the last polynomial, mn plus 4. Okay. And I'm going to do my distribution. So I'm going to distribute m squared n squared times both of these over here. So that's going to get me m cubed n cubed. And multiply that by 4, so I get plus 4m squared n squared. Then I take the mn and distribute. So minus m squared n squared minus 4mn. And now my negative 2. So minus 2mn minus 8. Once you combine like terms, put in standard form. Remember, standard form means the first variable in descending order. So first variable in descending order. So my first variable here are m's, so I need to go m cubes, then m squareds, then m's. So m cubed, n cubed, that's the only one I have that stays. M squared, n squared, so I have 4 minus 1, so plus 3m squared, n squared. 4mn, negative 4mn minus 2mn, so minus 6mn minus 8. That is my answer in standard form. Let's do another one of those. Again, it doesn't matter the first two that I choose to multiply together. I just always take the first two. So mn plus 1 times m squared n minus 1. And then multiply these two together. So I get m cubed n squared minus mn. Now distribute the 1. plus m squared n minus 1. Combine like terms. I don't have any like terms there. So all of that stays. So m cubed n squared minus mn plus m squared n minus 1. All of that times that last one, mn squared plus 2. So if I distribute this first one with both of these, I'm going to get m to the fourth n to the fourth plus 2m cubed n squared. I'm going to take this one and distribute with everything over here, minus m squared n cubed, because remember I add exponents, minus 2mn. Now the m squared n, so it gives me plus m cubed n cubed plus 2m squared n, and finally my negative 1, minus mn squared minus 2. That's a lot, right? So now I just need to combine like terms, and remember I start with my m, my first variable, in descending order. So m to the fourth, n to the fourth. That's the only one I have, so it stays. Next I want my m cubes. So let's see, I have it m cubed n squared, okay? Do I have any n cubed n cubed? That would be next. So this one is going to be next. So plus m cubed n cubed. Now I need m cubed n squares. So m cubed n squareds gets me right here. So plus 2m cubed n squared. Now I'm going to do m squareds n cubed. So m squared n cubed, m squared n. So this one would come first. So minus m squared n cubed plus 2m squared n. Now I went from m squareds down to m's. So this one has the n squared, so it's going to go next. Minus mn squared minus 2mn minus 2. All right, that big monstrosity is our answer. Okay. All right, now we're going to quickly talk about understanding closure. So it tells me that the set of real numbers is closed under addition. If a and b are real numbers and a plus b equals c, then c is also a real number. Adding like terms does not change the variable factors of the terms, only changes the coefficients. Since a and b are real, a plus b is also real. The exponents are unchanged. The sum is still a polynomial. So the set of polynomials is closed under addition. Using the same logic, you can determine that the set of polynomials is also closed under subtraction. So then the next question asks, is the set of monomials closed under multiplication? And explain. Okay, so will two monomials that I multiply together give me a monomial back? So let's just try it out. Let's take two monomials. So monomial is just one term, right? So I could say 5x squared, that's a monomial, times, let's say 10y. I multiply those two together, I would get 50x squared y. I still just get a monomial. So yes, the product of two or more monomials will always be a monomial. Therefore, it is closed under multiplication. That's where we're going to stop for day one of adding, subtracting, and multiplying polynomials. Tomorrow we will look at comparing polynomials and writing polynomial functions.